In this video, I'll show you how you can create a full crypto-based play-to-earn game using thirdweb, next.js, TypeScript, as well as Solidity to create our own custom smart contract. By the end, you'll have an awesome looking game exactly like this, where we have 2 NFT collections, an ERC20 token, and an awesome little Solidity smart contract that allows users to start earning ERC20 tokens for participating in the game. So if you're excited for this build and you want to see more awesome Web3 content like this for free, remember to like the video as well as subscribe to the channel. But with that said, let's jump right into the video. The first thing we'll do is we'll head to the thirdweb dashboard and deploy the NFT collection for our characters of the game. So if you go to thirdweb.com, click on the start building, you'll be prompted to connect your wallet, as you can see here. And then from there, you'll be able to deploy a new contract in the top right here. So go ahead and click deploy new contract. And from this page, you'll be able to see all of our pre-built contracts down here with the author of thirdweb. And what we're interested in for our character collection is the edition drop contract. So we have one NFT multiple owners, which follows the ERC-1155 standard. And what this edition drop contract does is it provides a way to release or drop those ERC-1155 NFTs. And 1155 is just a standard where you can have multiple quantity or more than one quantity of each of the tokens in that collection. So it's kind of NFT, they're sort of known as semi-fungible tokens, where instead of you just having one-to-one mapping of token to owner, you can have multiple owners of the same token or multiple quantity of that token. So what we're going to do is we're going to upload the metadata of our contract here. And if I go ahead and find this on my end here, we're going to upload this little character for our collection. And this is the character for our game. So everybody is going to receive a character that looks like this when they actually play our game and try and claim an NFT. But this contract metadata is actually the metadata of the contract itself. So it's not to be confused with the NFT metadata that you're going to be uploading in just a short moment. So this is the metadata of the contract. So let's call this the miners contract. And then the symbol can just be miners. And let's say these are the characters for our game. And then down here, what we're going to do is we're going to select the Mumbai Polygon test network. And if you don't know what a test network is, or if you've never used the sort of blockchain or deployed a smart contract to the blockchain before, we'll have a resource for you to get started with some test funds, as well as set up with a wallet. And then you can jump back into where we're at now. But if you are familiar with deploying contracts to the blockchain, then go ahead and click this deploy now button. And it looks like it's prompting us to switch to Mumbai, which I'll go ahead and do. We'll switch network and we'll deploy the contract here. So while that's loading, what I can kind of explain is how these pre-built contracts work. So you see in just a short second here, we're prompted to accept this deploy proxy transaction. I'll go ahead and confirm that so it loads in the background here. But if we take a look at this diagram here, you can see what's actually happening when you're deploying a pre-built contract. And what you're doing is you're deploying a proxy contract over the thirdweb base contract. And in kind of simplified terms, without going too deep into the technicalities, essentially what you're doing is you're deploying a contract that delegates the calls to sort of key functions to thirdweb's base contract that we've deployed. So we've deployed that sort of core foundational logic for the edition drop contract. And what you're deploying is sort of the things that are different to other people's edition drop contracts. So things like the name and the metadata that we uploaded and all of that kind of stateful information, like what NFTs have been minted into the contract, is sort of stored in your world, but all of the logic like minting NFTs and transferring NFTs would all be the same across every edition drop contract that has been deployed via thirdweb. So what we've done in version 2 of thirdweb, which has been out for quite a while now, so it's not really a new version anymore, but what it does is it sort of delegates those calls to the thirdweb base contract and then runs that core logic, since it's the same for every edition drop contract, and then passes that information back to your contract for you to store that information. And the important thing to note is you still have 100% control over the code and the contract that you're deploying. It's just that the calls, since all of that logic is the same across every pre-built contract, that is being delegated to thirdweb's base contract that we've deployed. And what that means for you is it's around 10 times cheaper in terms of gas to actually deploy this contract, since every line of code that you're deploying to the blockchain cost you gas to deploy, and cutting out that logic and delegating it to the base contract is an excellent way to sort of decrease that gas cost when you're deploying to that blockchain. So it looks like that transaction has gone through. And as you can see now, we have the dashboard for our smart contract. You can see we have things like the contract explorer here, where we have all of the read and write functionality. So we have things like the read functions of the roles, the balance of a user to see how many tokens they have, contract version, contract URI, all of this good stuff. And we can actually execute these functions directly if we wanted to from the contract explorer. But what we're interested in is actually minting the NFTs, or lazy minting the NFTs into our contract. So if we go over to the NFTs tab, we'll be able to see this single upload as well as the batch upload button. And what we're interested in is this single upload, since we'll only have one character NFT. I've only got art for one. And what we're going to do is we'll upload this file and we'll upload our character. And now this is the metadata of the actual NFT itself. So if we go ahead and say a thirdweb miner, I guess, and then the description can be characters for the P2E game. And down here you can add properties. So I guess we're going to add some. We can say his shirt looks like green to me. And then looks like at least a little bandana on there. So we'll say bandana is red. And this is just extra kind of metadata that's going to show up on sites like OpenSea and is actually associated in your NFT's metadata. So if you're happy, we'll click this lazy mint NFT transaction down here. And this is going to lazy mint the NFTs. Now, if you don't know what lazy mint means, we're not actually minting the NFT into our wallet with this transaction. All we're doing is we're sort of preparing this metadata onto the blockchain so that other people can mint the NFTs. So rather than paying the gas fees for minting the NFTs into the contract itself, what we're going to do is we're just sort of preparing it, and then we'll have other people come in and claim and mint those NFTs into their wallets and pay the gas fees for those transactions. Looks like that transaction has gone through. And if we give it a second to load here, we'll be able to set the criteria for sort of the conditions that these NFTs can be claimed under. So we click the actual NFT here and we go over to the claim conditions tab. You see no claim phases have been set yet, but what we'll do is we'll add the initial claim phase here with this big purple button. We'll click that and you can see we can outline all of this criteria of how other people can mint this NFT. So you can see we have things like when will this phase start? How many NFTs will you drop in this phase? How much do you want to charge? What currency? Who can claim? So you can upload an allow list and a CSV file. And you can see how many NFTs can be claimed per transaction, how many seconds do you have to wait between claiming. So you can set all kinds of things. I'm losing my breath even just listing them out. But what we're going to do is we're going to have a free NFT drop. So we'll leave the price as 0, we'll leave the currency as Matic, and then we'll change one thing down here, which is you can only mint one NFT per transaction. So you can only mint one character every time you claim from the drop. And we'll set this second field of how many seconds do you have to wait between claiming to be unlimited. And that means from the drop, you can actually only mint once per wallet. And we'll go ahead and accept this multi-call transaction here to update the claim conditions on our contract. And it looks like that transaction has gone through. So we can exit out of this sidebar here. And that is it for our player character, or our miners contract as we called it. So this is going to be the characters that the users can claim in our game, and they'll earn this NFT just for claiming from that NFT drop. So we're going to go ahead and do the exact same process now. We're going to deploy another smart contract that is of the ERC-1155 drop variety, but instead of characters, this time it's going to be for the tools of our game. And instead of just setting it for free, what we're going to do is we'll sell the tools of our game in a custom currency that we're going to create. So first we'll need to create that custom currency. So if we go back to the dashboard here, connect your wallet again if you need to, and then click the deploy new contract button from the top right here. Instead of the edition drop this time, what we're going to deploy is actually a token. So we scroll down here and click the ERC20 Token Preview contract, And what we can do again, as the same process as last time when we created the characters, we can upload the metadata of this contract. And this time, instead of characters, it's going to be gold gems. And as I said before, you can grab the artwork as well as see the original talented artist that created this artwork in the project in the description below. So if you are interested in using this artwork for your project, feel free to grab it from the description here. And what we're going to do here is we're going to call this token, the ERC20 token. We're going to name it gold gems. And we have this pretty image of gold gems here. We'll call this gold and we'll give it a description. So this is going to be, well, this is the reward for playing our game. And once again, we'll go through the same process of deploying the contract onto the Mumbai Matic test network. And we'll just approve that transaction and we'll see you in the dashboard again. All right, so here we are in the dashboard for our ERC20 token. And instead of the NFTs tab here, you can see we have this tokens tab where we can actually see different kinds of information since this is a different kind of token. So you can see we have the total supply, which is 0 since we haven't minted any tokens. We have how many I own, which is obviously also 0. And the decimal places, this is just sort of a standard for having ERC20 tokens on the EVM sort of environment. And what we can do is we can, instead of lazy mint, we're just going to mint an additional supply. And let's just go ahead and say, let's mint, I don't know, 1,000 of these gold gems. And then we'll be able to sell the tools of our game in this gold gems token. So you can kind of see where we're heading with these different kinds of smart contracts integrating together. We're going to have a character contract, we'll have a tools contract, and from the tools contract, you'll be able to use this ERC20 contract to actually pay for the NFTs within that contract. So you're kind of building out your own little world where you have a currency, you have things you can buy with that currency, and it's all stored on chain. So now you can see we have a total supply of 1,000. I apparently own 0, and that's sad. I've got no gold gems, but that's all we need to do for our ERC20 smart contract. So now we're going to go back to the thirdweb dashboard and we'll create another edition drop smart contract so that we can create those tools. So let's go ahead and click deploy new contract. We'll go back to edition drop down here. And instead of our little character this time, we're going to upload this pickaxe here. So we'll say tools, and we'll give it a symbol of tool, if I could spell. And this is the tools for our P2E game. And we'll go ahead, the exact same process again, just to get yourself familiar with how you can deploy these pre-built contracts. So this is the third and final pre-built contract that we're going to do. And after this, we'll jump into Solidity and start coding out our custom contract that kind of brings all of these contracts together. So you can go ahead and accept that deploy proxy contract again. And instead of just one NFT in this contract, what we're going to do is we'll mint multiple different kinds of tools that have different claim conditions. So you can actually set claim conditions on a per token basis in the edition drop contract. So once we go ahead and upload the NFTs, which I'll do our screen since this information has kind of already been shown to you. I don't want you to sit there through me minting 5 different NFTs, but maybe what I will show you before I go ahead and do that off screen is how you can use your custom currency that we just created. Go back to the dashboard and we'll grab our contract address of our gold gems. Here we go. Looks like we're back at our gold gems. So go ahead and copy this address to your clipboard. And then what we'll do is we'll single upload. We'll upload let's start out with a stone pickaxe. So we'll use the same asset here. So this is going to be a stone pickaxe. And we'll just say this is the worst or cheapest pickaxe there is. And you can upload any additional metadata. I'm just going to keep it simple and lazy mint it with that information here. And what we'll do in this contract is we'll have 5 different kinds of tools that you can actually buy from this edition drop. And it gives us this kind of shop feature in effect where you can come into the shop and pay with your gold gems to actually buy these tokens or mint these tokens in reality of what you're doing, and then pay and sort of earn more tokens based on the power level of these tools that you're buying, and earn more tokens, buy stronger tools, earn more tokens. And it kind of gives that full environment where you have these tools and these rewards all stored on chain. So it looks like that's gone through. Now we've lazy minted it. And what we'll do is we'll go through that same process where we set the claim conditions, but we're going to do one really important thing this time, which is set the currency to be the gold gems. So we can say, what currency do you want to use? We'll use custom currency down here. And what we'll do is we will paste the contract address of the gold gems token that we created up here. So we'll copy and paste that into this custom currency here. And I'm just going to leave this tool as free. So this custom currency isn't that important since this tool is free. But for the other tools, I'm going to make them increasing in price. So for the second token, I'm going to set the price for the tool to be 10 gold gems. So you can see how we're selling these NFTs in our custom currency that we've just created now. But just for simplicity for this first token, I want people to be able to start playing the game for free. So we'll set this to be 0. Once again, you can only claim 1 per transaction, and you can have to wait unlimited time between those claims. You can only claim 1 from the drop. We'll go ahead and save those claim phases. And what I'm going to do is I'll mint the 4 different, or lazy mint the 4 other NFTs that we're going to create in this tools collection off screen, so you don't have to watch me sit here and do this 4 more times. But what I'll do is I can actually bring this into frame here. I've got it set up already. Little editing magic, and you can see we have these claim phases here. So for stone pickaxe, we have the claim phases, just give it a second to load. The stone hammer, we have the claim phase where the price is 10 of those gold gems. So you can see the free for the first pickaxe, the 10 gold gems for the second pickaxe, and the green wand here, we have a claim phase where I think it is around 50 or 100. Yep, looks like it's 50, so you can pay 50 gold gems for the green wand, which I guess gives you more power, is what we're going to implement in the mining contract. And what we'll do is each token ID will actually give you a multiplier of how many gold gems you earn for playing the game. So to begin with, you'll have the stone pickaxe. We have a rewards multiplier of 0, and we'll add 1. So you actually earn something, obviously. So the rewards multiplier will be 1 for token ID 0. The rewards multiplier for token ID 1 will be 2. So you earn double the amount of tokens for using the stone hammer or increasing your power level in the tool. And then for the green wand, you'll earn triple the amount that you would in using the stone pickaxe. So the token ID is actually going to be used as the rewards multiplier for the mining contract that we're going to build out now. So let's go ahead and jump into the Solidity environment. Once you've kind of set up a similar setup to this, feel free to have fun with it and create your own metadata, or if you want to use the same as I am, the link to all of this information will be in the description. You can grab the same metadata as I am, and you can jump in to the Solidity environment as we're about to do when you're ready. So now that we have our 3 pre-built smart contracts set up, we have the gold gems, we have the pickaxes, and the thirdweb miners. What we can do is we're going to jump into the CLI here, and we're going to create a Solidity environment where we can use thirdweb extensions to build out our own smart contract with custom logic. So the first thing we do is run the npx thirdweb create -- contract command. And it's going to ask you to give the project a name firstly. So we'll say contract. And I'm going to be using Hardhat for this project. So we'll select Hardhat and go ahead and run the empty contract just so we can set up with a blank slate. And this is going to set up a basic Hardhat project where we have an empty Solidity smart contract that we can use to interact with these 3 pre-built contracts and then add our custom logic on top. So once that's done, we can run the cd contract command. And we'll open that up in the code editor of your choice. I'm going to be using Visual Studio Code for this video. As you can see here, we have the Hardhat config. We have the actual smart contract in the contracts folder here. Obviously, it's not doing a whole lot, as you can see, but we have an empty contract. And if we run the terminal here, we can run the yarn build command, and this is going to compile our contract and then run the npx thirdweb detect, which detects any of the contract features or contract extensions that we've implemented. And since our contract doesn't do anything at this point, it's just compiling that, and it looks like there's no errors. So we're happy, we're set up with this Hardhat environment now. Let's go ahead and start adding our logic for this contract. So I've cleared out the existing code that we had in this contract.sol file, and now we're ready to code up our logic. And remember, you can always access the full source code in the description for this project. If you don't want to watch me walk through step by step what is happening, you can see the full product in the description on GitHub. So first thing we need to do before importing is set the Solidity version. I'm just going to use or 0.8.11. There's no reason I'm doing that. It's just whatever I chose at the time. And then we are importing the thirdweb contracts that we just deployed. So this first import here is the drop ERC-1155. If I zoom in a little bit, we have the drop ERC-1155, which is the NFTs that we created for the pickaxes. That is the drop ERC-1155 contract. So we're importing that contract so that we can use the logic or the functions available on that contract that we deployed via the thirdweb dashboard. So we're kind of importing the pickaxe contract that we've just defined in the thirdweb dashboard. And we're doing the same here for the token ERC20, which is the gold gems contract that we created. So we're going to set these values as the contract addresses that we've deployed when we create and deploy this contract. And you'll see that in the next lines here. So beneath that, we have some more imports from OpenZeppelin, and we have the reentrancy guard to protect ourselves from reentrancy attacks. We have the ERC-1155 holder that comes from ERC-1155 utils, which just means our contract is capable of accepting transfers of ERC-1155 tokens and storing them in our contract. So that's going to be helpful when we try and let users stake their pickaxe NFTs into our contract, and then this contract is actually capable of accepting that transaction and storing those tokens. So now we've got our imports sorted. We can define our contract. Contract is called mining, and it's inheriting the logic of reentrancy guard and ERC-1155 holder. So this inheritance is just sort of incorporating all of the logic that we've imported from these two OpenZeppelin imports into our smart contract. So now our contract is capable of holding ERC-1155 tokens, and it is also going to implement reentrancy guard. So beneath the definition of our contract here, what we have is we store the addresses of the two other contracts, and the two other contracts here refer to the addition drop of the pickaxes. So we have the immutable variable called pickaxe NFT collection that is of type drop ERC-1155. So you can see why those imports are especially useful for us here, where we're defining the pickaxe NFT collection, which is really just an address. But when we go to call things like pickaxe NFT collection dot transfer, we'll be able to use that functionality because we are aware of that type. Now, there are a few other ways you could do this. I'm not saying this is the best way. This is just the way that I chose to do it. So if you are aware of a better way that you're more comfortable with, feel free to do that. These contracts are quite large in size, so this is definitely not the most optimal way to do that, but this is the way that I've chosen to do it in this smart contract. So if we continue coding up our contract, we have the next line here. We have the constructor that takes in the addresses of the pickaxe contract as well as the gems contract address. And we're just setting those variables when this contract gets deployed. So we accept two parameters in the constructor, which is the function that gets called when you deploy the contract to the blockchain. We accept a pickaxe contract address, which is our pickaxe NFT collection, obviously, and we'll copy and paste that from the dashboard when we go to deploy it. And we have the gems contract address. So we're accepting them in the constructor at deploy time, and then we just set those variables, and those are immutable. So there's not going to be change in those smart contracts once they are set. Beneath the constructor here, we have a struct map value. And within this struct, we have two fields. This first field called isData is just a Boolean that we can kind of flick on and off depending on whether the NFT or the data is still currently staked. So the isData will be true when the NFT is staked. So they haven't sort of unstaked that NFT, and then the value will actually store the token ID of the NFT. So the isData will be true while they're staking. The value will be the token ID of the NFT that they're actually staking. And we'll use this map value struct for the two mappings that we're going to create. The first mapping is called player pickaxe. So as the name suggests, this is a mapping from wallet address as the key to map value, which is going to store the uint256, which is the token ID that the wallet address is currently staking. And the isData will suggest that the value will be true if that NFT is being currently staked, and it will be false if that NFT has been unstaked. So we'll use the map value struct. That's probably not the best name. You can feel free to rename that as you choose, but it's just for this purpose of demonstration here. We'll use this map value for this mapping here. And then beneath this mapping, we'll have another mapping called player last update. Now this is going to play a crucial role in determining how many tokens we transfer to the address when they go to claim their tokens. So we'll store the last time that they claim claimed or had their rewards paid out in this mapping. So this is going to be a mapping from address to map value again. And the value this time is going to store the timestamp of when they last had their rewards paid out. So this is going to say, let's say, for example, I had my NFT staked from timestamp number 0 to timestamp number 100. We'll read this value and we'll say, okay, Jarrod has had his NFT staked for 100 seconds now, since the time now is 100 and he last staked it at 0. We'll read this value and we'll say, okay, we owe him 100 gem tokens, just to keep it simple. Let's say we were paying out 1 gem per second. So you can kind of see how this plays a part. The is data will say if this data is actually here, and the value is going to represent the last timestamp that they claimed or had their rewards paid out. And you'll see why this is more relevant as we sort of build out the rest of the smart contract. You can see, as the comment suggests, we have mapping of player address until the last time that they staked / withdrew / claimed their rewards. And by default, the player has no last time, they will not be in the mapping. So that makes sense. Beneath this, we have our calculate rewards function that takes in an address, or wallet address. You can see we have this comment here. We have calculate the rewards the player is owed since last time they were paid out. And that is going to use this player last update mapping as we write the code for this function. So this is calculated using block.timestamp and the player last update. If that value is not set, then the player has no rewards. So let's build out the logic for this contract or this function here. The first thing we'll do is we'll check to see if the player last update or the player is in the mapping, and that value is not 0. So we'll say if they're in the player last update mapping, and if they're also in the player pickaxe mapping. So if they have a currently staked NFT, and if they have ever been updated before. So that's kind of a little bit confusing, but what's most important here is this check, is if they currently have an NFT staked. So if that is data field in our original mapping is true, then we owe them some rewards, since they have sort of had an NFT stake since last time they claimed their rewards. So that check is just basically saying if they don't have an NFT staked, then, well, basically they have no rewards to be paid out. So beneath that check, we have a check to calculate the time difference between now and the last time they had their rewards paid out. So this is using this player last update mapping again, where we say the time difference between now and the last time that they claimed their rewards is the difference between the timestamp and the last time they claim their rewards, which is stored in that mapping there. So you can see how that player last update mapping is coming into play already. And beneath that, we have the time difference. We have this rewards calculation here where we say, calculate the rewards they are owed in this uint256 rewards variable. We have the time difference multiplied by 10 trillion, it looks like. And you have to remember, you had to divide the value you want into 18 decimal format. So if you remember on the dashboard, when we created the gold gems token, we have this kind of specificity of 18 decimals. And this is why this number is so big, because it's just being formatted for 18 decimals in how many rewards we want to pay out. So just keep in mind when you're setting this value here, you want to keep in mind that it's actually in 18 decimal format. So if you have 1 here, this is just going to be very, very minuscule compared to the number I have. So we have the time difference multiplied by 10 trillion divided by 18 decimals. Then we have this rewards multiplier that we were talking about in the player pickaxe NFT collection. So we have the value, the token ID of the NFT that they're currently staking, plus 1 is going to be the rewards multiplier based on also the time difference and this kind of hard-coded value of number of gems that we're sending out per block that is passing by. So you can see here, the value that they're being paid out is being multiplied by the token ID. So if they're staking token ID number 1, their rewards are going to be times by 2. So 1 plus 1 is obviously 2. And then if they stake token ID number 4, let's say, they'll have a multiplier of 5. So you can see how our kind of game mechanics are being integrated into the actual Solidity smart contract itself. So that is where the rewards multiplier based on the token ID comes into play. And this is calculating the time difference and the hard-coded value of how many gems. So if you want more gems or how many currency you are implementing into your game to be paid out. You can vary this number to be more or less depending on your currency. Beneath the rewards, we actually just return that value. So that is just a view. For each player, we can calculate the rewards that they are currently owed so that we can call this function in the rest of our smart contract when we write the stake function, the claim function, and the withdraw function. So let's go ahead and write those now. So now that we have that internal calculate rewards function, we can write the stake function here, which is going to take in a token ID. That the token ID is going to the pickaxe that you're going to stake. We'll say this is an external non-reentrant, so we're utilizing the reentrancy guard here. Within the stake function, we're going to require that you actually must have a pickaxe to stake. So we're checking the balance of the message.sender, which is the person or the wallet address calling this function. We're checking to see if they have a balance of the token ID that they're trying to stake greater than 1. Otherwise, they fail this check and they can't call this function. And we send them a message saying you have to have at least one of the pickaxes you're trying to stake. So that's just kind of a safety check before we call the core logic of this function here. Beneath that check, we say if they have a pickaxe already staked. So we say if the mapping of this wallet address .isData is true, then we send that back to them. So beneath this code block or in this if statement here, we say pickaxe NFT collection .safe transfer from, which is transferring from this smart contract to the person that called this function, the token ID that they currently have staked. The quantity here is just 1, and the data, the message that we send with that transaction is just say, we're sending your old NFT back to you. So now we have the calculate rewards. So every time they stake or withdraw or claim, they're going to be paid out the rewards and the mapping will be updated. So we'll calculate the rewards, pay them out. We'll say rewards token dot transfer to the person that called this. The amount is the amount that we calculated from this internal function that we have down here. And now we can get into the actual staking part. So instead of sending it back to them, now we're saying we're transferring from you to our address, and this is going to require a special approval that we're going to provide on the front end before we call this function, because by default, the smart contract won't have the permission to transfer somebody else's tokens unless you explicitly provided that. So we're going to do that on the front end. The safe transfer from, so we're saying we're sending it from the wallet address to this contract with the token ID, and 1 is the quantity again, and the message is just staking your pickaxe. Beneath that, we have a very important step where we're updating the player's mappings. So we set the value to be the token ID in that player pickaxe mapping, and we set the isData to be true to suggest they are currently staking. And then in this check, now they'll start accumulating those rewards in this if statement here. So we'll say if the isData, which will now be true, then this statement is no longer true. Since they do have a pickaxe actually staked, we can actually start calculating how many tokens they are owed. Beneath that, we have the update of the other mapping, where we have the player last update is now being set to the current timestamp, which is also utilized in this calculate rewards, where we say, based on the time that they staked, this is how many tokens they're owed. So this kind of process is we send out their existing rewards, and then we update after they've staked their new NFT. Great, so now we have our stake function written. What we'll do is we'll write the withdraw function, which is pretty much just going to be the exact opposite of the stake. So we'll set these values to false, we'll send the token back to them, and we'll also calculate and pay out those rewards. So we might quickly go through this, where we say you have to have a token actually staked to send it back to you, obviously. And then we go into the calculation of the rewards again. We then transfer those rewards back to the wallet address that called this function. We transfer the token that they're owed from this address to the sender. The value, the token that we're actually transferring is the one they had staked in the mapping. We have a quantity of 1, and we say returning your old pickaxe. Beneath the transfer back from the contract to the address, we have the update of the mappings. So we're just saying the player pickaxe mapping updates to false, as well as update the timestamp that this player last claimed their rewards. So the final function, the third function that we're going to build in this contract is going to be the actual claim function. So you can claim your tokens directly, even though that logic exists in the stake and withdraw. We also have a function to actually just claim the tokens from the contract that you're owed without staking or unstaking. So within this claim function, we'll just call the same logic where we have the calculation of those rewards. We pay out those rewards to the person that requested them, and we update the mappings to reflect that information. And that is it for our smart contract. So we have a way of staking, we have a way of withdrawing the tokens that you've staked, getting the tokens back, and a way of claiming the rewards that you're owed based on that time calculation in this internal calculate rewards function that we have here. And at any time you can call this, since this is public, you can actually just pass in any other player's address to see how many tokens they're owed, and then that is it for our smart contract. So what we can do is we can actually go ahead and open up the terminal here. We can deploy our contract using the command npx thirdweb release. What this is going to do is it's going to compile our smart contract. So first you can see, looks like it's failed, but if we go back up, it says the detected project type was hard hat, compilation has failed. So it's attempted to compile our project before it goes to release it. And if we take a look here, we can see the solidity version pragma statement in these files don't match. So it looks like we've got the wrong solidity version configured in hard hat config. So change that to 0.8.11. And let's try and run this npx thirdweb release command again here. Actually, before we do, I am already preempting that this is going to complain about not having OpenZeppelin contracts installed. So we're importing, but we haven't actually installed the OpenZeppelin packages. So let's go ahead and run npm install at OpenZeppelin/contracts. It's going to go ahead and install OpenZeppelin contracts. And we also need to install npm install at OpenZeppelin/contracts-upgradable. Cool. All right, we've installed those two packages. If we take a look at our package.json, you can see we have both the OpenZeppelin packages as well as the web dev contracts here. And if we try again for third time's the charm, we'll run npx thirdweb release again. And as you can see, it attempts to compile our projects, spits out another error we have here. So it looks like we have a conflicting import from thirdweb and OpenZeppelin. So this is because thirdweb actually provides some of the functionality that OpenZeppelin has. So if we take a look at node modules here in the thirdweb dev/contracts, here you can see we have OpenZeppelin presets. And in here, in the utils folder, it looks like it's unhappy about that we have this file called ERC-1155 holder, as well as the one that we're importing. So instead of the one that we're importing from OpenZeppelin here, what we can do is go ahead and delete that. And instead, we can import the one from the thirdweb dev package. So we can import the one that we're importing from thirdweb dev. So it's at thirdweb dev/contracts, at thirdweb dev/contracts / OpenZeppelin-presets, OpenZeppelin/presets. Then we have utils, ERC-1155/utils. Here we go. /utils/ERC-1155. And now if we click into this, that is now being imported from the thirdweb package and shouldn't be conflicting anymore. So if we run npx thirdweb release, let's clear this out before we do it. npx thirdweb release. This should hopefully no more errors. This should compile our project. It's going to upload the compiled version to IPFS. So as you can see, thankfully it has compiled successfully. It's now processing it. It's uploading the compilation to IPFS. And what it's going to do is it's going to spit out a link where we can release our contract, which is not just deploying it just yet. We'll show you what release is going to do. It's going to spit out that link, and then we'll have a landing page fully generated for our smart contract. So once that's released, we'll be able to make further versioned releases of the same smart contract. So we'll initialize this release by saying npx thirdweb release. We'll upload the information about our contract, like its name, its purpose. We'll have a README that we can upload Markdown into. So we'll go ahead and open this up. I'll show you what I'm talking about here. open that up, which provides us with a link to the thirdweb dashboard. As you can see, we're about to create a release. We're loading that information that we just uploaded to IPFS of our contracts ABIs. So we have the name, we have the descriptions. As you can see, I have deployed this contract or released this contract before, so that's why it's showing up here. So it's trying to release a new version of the contract that I've already released. So it thinks that I'm updating the previous version. For you, it'll probably look a bit different. But let's go ahead and upload the logo for our mining contract. Let's give it a description. This is our play to earn game. And here we can upload what this contract is about. So we can upload any markdown into this about field here. So we can say mining P2E game. Zoom in a little bit for you. Mining play to earn game. Hello world by Jarrod. And then I'll set this version to be 1.0.1. This is an iteration of a previous release that I made of 1.0.0. So I've updated the smart contract and now I'm making a new version of this release. And as you can see, you can put an audit if you have one. I obviously don't have one. And then you can add any versioned release notes. So I believe if we wanted to, we could actually provide some valuable release notes here, since the previous version of this contract was using version 2 of our smart contracts package. So let's say this now uses v3 of @thirdwebdev/contracts. If we zoom back out, we can now click create release and switch to Polygon, switch network and create release. And while that's happening in the background, I'll kind of explain what we're actually doing here. So we've uploaded our contracts compilation, our ABIs to IPFS. And now we're deploying a release onto the Polygon blockchain. And what that means is you're uploading it to thirdweb's contract registry, where all this metadata that we uploaded, as well as the source code for the contract itself, is actually stored in this version on the Polygon blockchain. So you can see we've successfully released this contract, and now this information is being pulled from the blockchain directly. And as you can see, this is being associated to my profile here. So you can see it is released by me. We have the new version. So the previous version, you can see 1.0.0. Obviously, I put some gibberish in here when I released it for the first time, but we now have the latest versioned release of the 1.0.1. We have the release notes for this upgraded version. We have the title, the description, all of that stuff we wrote about in the metadata. We have the released on. So it looks like I released this version on today. It has the unlicensed version of the Solidity contract. Since we defined that in line 1 here, we don't have a license. And all of that information, as well as the write functions and the read functions, the source code is all being pulled onto this versioned release onto the thirdweb contract registry. And what other people can do is you can actually go to this page. If I share this link will be in the description. If you want to completely skip the contract development step, you can actually just go to this page and click on the deploy now button, which is where you'll be allowed to first of all, enter the parameters of the constructor, which we're about to do, and then deploy onto any of our supported blockchains. So you can see, you can add this contract release. You can go ahead, deploy your own version to any of the networks in this list here, as well as sort of get a quick overview of what's happening, inspect the source code before you deploy it. And since this is my profile, I can go ahead and edit my profile here. And this is my test account and my beautiful face up there. And all of that information is stored on the Polygon blockchain. So now that we've released it, and if you want to check this out, this will be in the description as well, you can go ahead and deploy it from this release page, which is about what I'm going to do now. So firstly, we need to get those contract address parameters. If we go back to our dashboard here, I've got it up over here. We need to get the address of our smart contracts. So let's copy the address for the gold gems. Let's also copy the address for the pickaxes here. So let's go back to our pickaxe contract address field here. So we'll paste the pickaxe contract address in. We'll also paste the gems contract address in. So now we've got our constructor set up. We can go ahead and deploy this to the Mumbai Matic test network. Going to ask us to switch wallets, switch networks again here. And then we can go ahead and deploy the actual contract itself onto the test network. Go ahead and confirm that transaction. And now, rather than just a release page, we actually deploy the code that we uploaded for that release onto a blockchain of our choice. And then we'll have our own custom dashboard, which is kind of what we saw earlier with the pre-built contracts, where we have a version of that contract which is specific to us, which is what we see here. We have the contract explorer, where we can now actually run those functions that are in our smart contract, rather than just sort of see what's available. So now we could be able to run, let's calculate the rewards for me, let's say. We'll copy our address from MetaMask here, and we'll paste this into the player field, and we can calculate the rewards. This should obviously be 0 since we've never staked a token before. As you can see, that has been set to 0. All right, so now we have the events, we have the code, we have the settings, sources, and what we're going to do now that we have all 4 of our smart contracts deployed is we're going to build a awesome application on top where users can claim NFTs from our character collection. They can also buy NFTs from our pickaxe collection, and then they can stake their pickaxe onto the mining contract that we've just deployed to earn the gold gem tokens that we created using that ERC20 token smart contract. So now we'll jump back into the CLI, open this up. We'll change directories out one, so we're back in the root folder here of our project, and then we'll run the npx thirdweb create --app command this time. So the first time we ran contract, this time we're running app. Let's call this application. So this is going to be the front end side of our application, whereas the contract is the sort of back end foundational layer. For this project, we're going to be using next.js as well as TypeScript. And what this does for us is it sets up a very basic sort of bare bones project with Next.js, TypeScript, and the thirdweb, React, and TypeScript SDKs pre-installed and pre-configured for us. And we'll see in a moment here, once these are done installing, we'll have a fully set up project, which we can quickly change directories into. So we'll change directories into application. We'll open this up in our text editor. You can see here we have the _app.tsx file, which will quickly change from being configured to mainnet to being configured to Mumbai, since that's where all of our smart contracts are deployed to. And then we have the thirdweb provider wrapping our application, which has the desired chain ID of Mumbai configured now. And then all of the pages within our application are wrapped in that thirdweb provider, which means that we can access all of the hooks available in the React SDK, as well as the UI components such as the connect wallet button, which is what we have on the homepage here, where we just have a very simple setup with a div containing the connect wallet component. So we're now going to get into creating the actual application to interact with our smart contracts. So I've just deleted the contents of the homepage, and the first thing I'm going to do in this repository or this project here is create a folder at the root of the project called const. And within that folder, we'll create a file called contractaddresses.ts. And what this file is going to be is kind of a constant value file that we can export the contract addresses of the 4 smart contracts that we've created, so that we can reuse those with variables rather than just hard coding the string values throughout multiple places inside our application. So it's just going to be much cleaner to import the contract addresses and use the variables rather than just hard coding them throughout our app. So for this, we're going to have the first one is mining. I'll zoom in here a little bit. So we have mining, we have pickaxes, we have characters, yep. And the final one we have is the gems. So we'll do export const mining address, and we'll grab these values from the dashboard. We'll just have an empty string value for now. We have export const pickaxes address is equal to empty string. We'll copy and paste this down here, replace the values with gems. So gems address and characters address. There we go. And now what we can do is we bring this into frame here, and we can copy and paste the address from the thirdweb dashboard. So we just click this button on our dashboard. So this is for the characters. Copy paste that in here. For the gold gems, we'll copy that, paste that into this value here. Pickaxes, copy that in. Repeat that process 4 times until we've populated this file. Let's get rid of these comments, it's kind of unnecessary. But now we've exported 4 constant values from this kind of configuration file, I guess you could call it. Now we'll be able to reuse these values throughout our application, which is going to be super handy. So if we go back to the homepage now, What we're going to do is, first of all, we're going to import all of the functionality that we're going to use on this page. And the home page is going to show a different state or a different display depending on the state that we load in from the contract. And that state is going to be different for each connected wallet address. So the first sort of UI that will render on the UI will show to the user is the connect wallet button. So we'll first ask the user to connect their wallet to the application using this connect wallet button component from the thirdweb dev/React library. So we have a type, which is just next page, which is just a TypeScript thing for rendering the functional component as a next page type. We're importing some styles, so I've copy and pasted some styles which you can use from the description if you're interested in having the same look and feel as I do in my application. That will be all available in the project in the description. So we're importing the next page type, we have the styles, and then we're importing connect wallet component, which we've described. The user address is going to detect if there is a currently connected wallet address to our website, and if there is, we'll be able to access it within that user address hook. So you can see here we have const address is equal to user address, and we'll display different values to the user depending on if they have their wallet connected to our site yet or not. And then the final two hooks we have are use edition drop, which is going to allow us to connect to our player character NFT collection, which we defined in this contract addresses here. So we'll connect to this contract address here using that hook. And then the used owned NFTs, as the name suggests, we're going to load the NFTs that the currently connected wallet address owns from the edition drop contract. So we'll be able to tell if a user has one of these player characters and show something on the UI, which in our case, we're going to show them a button that takes them to the actual gameplay after they have claimed an NFT character from the edition drop. So beneath that, we import our character edition address, which I think is named incorrectly here, but we can go ahead and fix that. And then we import the router from next router. So this is just importing the contract address for the character the character NFT collection. And then this is going to allow us to navigate to a different page, which we're going to create after we fill out this one. All right, so that's it for the imports. And then we can move on to the functional component here where we type it as a next page. So this is the home page. It is the next page of functional component, and we're going to write all of the logic inside of this component. So first up, we connect to our NFT collection address, the characters, which this variable is named incorrectly. We can go and fix that in a short moment. So this is characters address, not character edition address, but we'll get to that. So we're connecting to it using this one line of code, and we can access all kinds of information on this edition drop now. So we've connected to that. We have the contract itself in this one line of code and this variable stored here called edition drop. And beneath that, we're going to detect the currently connected wallet address. Beneath that, we'll use the next.js router to allow the user to navigate to a different page once they have detected that they own an NFT or they have claimed an NFT already. So that brings us to the use owned NFTs hook here. So here we're destructuring the data is loading and is error fields out of the hook or the object that gets returned from this hook called use owned NFTs. As you can see here, this allows you to get the owned NFTs for a specific NFT contract and a wallet address. So that's exactly what we're doing. I'm passing the edition drop contract itself here rather than just the address. So we're passing the whole contract in, and we're passing the currently connected wallet address if there is one. If there isn't, this will be undefined, and the data will obviously be an empty array. So that's the use owned NFTs. We have all of the data that we need to sort of show this conditional logic on the UI. So the first condition is if there is not an address, then we just want to show the connect wallet button. And that's pretty simple. We have this connect wallet button component here, and we can go ahead and customize that in a short moment with colors and kind of a color scheme and things like that. So beneath the address, so if there is an address, we'll reach this next step here where we'll show a loading state. So this is loading, if you recall, comes from the use owned NFTs hooks. So it takes a little while to come back with that information from the blockchain. So this is loading flag allows us to show just a loading screen, simple loading screen that says loading ... inside a div. And that is our next state where we're loading the information that we need to show whether or not we want to show the play button or a claim NFT button, which is what we're going to do now. And quickly just beneath that, we have an is error, which also comes back from this user-owned NFTs. So if something went wrong loading that information, which is pretty rare, it shouldn't really happen. It's just kind of a safe way of showing an error here. So we have error, something went wrong. You can kind of see how you could show something more meaningful rather than just me saying loading an error. You should show something a bit more meaningful and nice on the UI, but this is just keeping it simple for our UI here. So we've kind of got through all of the checks. We're not loading anything. We don't have an error. Something didn't go wrong. So we're ready to show this logic here, which brings us to one of the main screens where we have the actual mint container. So if they have an owned NFTs.length of 0, which means the array that came back from the use owned NFTs hook is 0 in length, they don't have any owned NFTs, then we'll show this component called mint container, which we haven't created yet, but you can imagine what that's going to be. It's going to be a component that allows the user to mint an NFT from the collection. And when they do, this use owned NFTs will be updated. And then once they do have an NFT, we'll show them this screen where they'll have a button that allows them to go to the /play page, the /play page as a tongue twister. And we're using next.js router as we defined on line 16 here to navigate them to that /play route. So we'll go ahead and create the /play route as well as the mint container now. And I think we have a little mistake to fix up here. So we have character address rather than character edition address. And instead of mint container, we'll go ahead and create the mint container component up next. So the mint container will create a folder at the root of our project called components first. And within the components, we'll create a file called mintcontainer.tsx. And within this component, what we can do is, first of all, we'll import a bunch of the logic or the things that we're going to use in this component again. So we have use claim NFT, use edition drop, use address. So use edition drop and use address we're familiar with already. Use claim NFT is another hook from the React library at thirdweb/React that allows you to claim or mint an NFT from an NFT drop contract. So we're going to claim and mint an NFT from our edition drop contract, which is our character collection here. And we have the Web3 button component, which is going to allow us to make sure the user has a wallet connected, as well as make sure the user is on the correct network that we outlined in the _app.tsx file here before we attempt to make that claim call. And as you can see, beneath the imports from our React components here, or our React library here, we have React itself, we have character addresses, the const from that contract addresses file that we created, and just some more styles. And I think I've just realized inside our _app.tsx file here, we're missing the actual import for the styles of the global style. So I'll just go ahead and copy and paste that in from our other application that we have here. So we'll copy and paste this in, and that should be good to go. So we just have global styles throughout our application. If you're following along with the styles from this repository, feel free to do the exact same. So back to our mint container here. Beneath all of our imports, we have an export of our functional component called mint container. And within the component, we'll again connect to our edition drop contract using that edition drop hook and passing in the constant value that we defined in that kind of config file. Beneath that, we have the use claim NFT hook, passing in the entire edition drop contract into that hook. And what we're doing is we're destructuring the mutate field out of the object that gets returned by the use claim NFT hook. And we're renaming the mutate to be called claim. And this claim function, or this claim field, is actually a function that we're going to call when the user clicks the Web3 button that we're going to define. So I'll show you that now. Beneath that, we have the address, so just to show which address we're going to mint the actual NFT to. So we have the UI beneath the hook. So we have a simple div with some basic styling just to sort of center it up. And beneath within the div, we have some context of what this is about. So we have an H1 tag to say this is the edition drop, and you can claim your character NFT to start playing the game. And here's just a little image that I thought looked pretty funny, where the character that we have for our NFT is kind of punching the air. It's supposed to be him mining to sort of say he's what you're going to be minting. Here's the metadata. So So we just have a simple image to showcase what you're going to be claiming from the NFT drop or the edition drop here. And beneath that, we finally have the Web3 button. And there's two things you need to pass into the Web3 button here. The first one is the contract address, which we're passing in the edition drop contract, which we created for our NFT characters. And the second one is called the action, which is what you're actually going to do on that contract. So what we're going to do is we're going to call the claim hook that we have here. So use claim NFT, we've renamed that to be claim. And when this button gets pressed, this action gets run, and you're calling this claim function with three sort of parameters here. So the quantity is 1, you're going to mint one of the characters. The 2 is the wallet address that we're actually going to mint to, and that is the currently connected wallet address. And the token ID is just 0, which is the actual character, the token ID of the character that we minted in that smart contract. And we just have some simple text here that says claim NFT. And I'll show you how you can customize this with the accent color here. So let's say we want, I'm just going to type in some random value here. Yep, pink looks good. And you can also set the color mode here. So I think our app is dark mode. So let's go ahead and open that up. All right, this looks good. So let's open up the terminal. What we'll do is we'll run the yarn dev command, or you can run npm run dev if you don't have yarn, and we'll go to localhost 3000. And once you're at the localhost 3000, you'll see that we have this first initial state here where we said if there is not an address, then we will show this connect wallet button here, which is what we're seeing. And we don't have any styles, so it's just the basic black and white button here, but you could add the color mode and the accent color if you choose to do so. And once we connect our wallet, so I'm going to go ahead and select MetaMask here, type my password in, you'll see we get that loading state. If I zoom in, that's pretty small, but then we see the play game button because this wallet actually owns one of these NFTs. So let's maybe switch wallets to a different wallet here. Let's connect our MetaMask wallet with this one. And I don't think this wallet does have an NFT. So we'll see that loading state again. And once that information has loaded from our smart contract, we see the next state. So once the address has been connected, we've skipped past this first section here. Then we see the loading state. So that's the next phase we see on the UI. And we've skipped, nothing went wrong, so we don't ever see the error. And now we're here where we see the mint container component. If we click into this, you'll see here's the stuff we just coded up. So we're seeing the metadata or the information that we're displaying inside this component. And then we have the Web3 button beneath that that is hopefully going to allow us to claim an NFT from this edition drop. So you can see we have the title, we have a description, we have our little man animation here. He's punching the air. So this kind of gives you a showcase of what you're going to mint before you actually click this button. But if we go ahead and click the claim NFT button, you'll see that it doesn't seem to be happy with us. Okay, why is that? Not exactly sure why that didn't work. Looks like we've got an error message here. So insufficient funds for gas price. Okay, so we don't have enough money in this wallet. All right, let's swap accounts to this one. So let's connect this wallet instead. And you could see how we could write this in a try catch block and show the error message on the UI, but I haven't had anything that catches the error here, so that's why we didn't see anything here. I just had a look in the console, and it looks like this wallet actually does have funds. So let's go ahead and disconnect from this wallet. So say disconnect from localhost 3000. Now we're back to the wallet that has no funds. I think it is this one. Okay, so let's disconnect from this one. Disconnect. And then what we'll do is we'll swap to account number 2 here. And I'll just show you quickly how you can actually get funds from a Faucet. So we'll go Mumbai Faucet. We'll go to this top result here, mumbaifaucet.com, paste our address in here, and we'll say send me Somatic. And you can see my address goes in there. We should receive some test funds that we can play around with within our wallet here. So if we take a little second to take a look at our wallet here, we should see 0.5 Matic. Okay, now we're ready to claim the NFT from our drop. So let's connect the wallet. We'll go MetaMask again. This time we'll connect with account number 2. We'll get that loading state. We'll get to the mint container state. We'll click claim NFT. And this time, since we do have the required funds to claim an NFT from the drop, we do see the MetaMask prompt here, and it looks like I've actually set the price of the NFT to be 0.0001 for this drop. That's why the transaction didn't go through. This is actually a different collection from the one we set up. Just so this isn't confusing why this has a price. In this collection, I do have a price. I know we set it up with 0, but it looks like I set it up to be 0.0001 testmatic for this NFT drop. So you can see how you can add a price to mint the characters if you choose to do so. And that's what's happening here. So we have this claim transaction. We'll go ahead and confirm that. And what that does is claims one of the NFTs from our drop. So this wallet that I'm currently connected with, this MetaMask wallet, which is OXA51, has just claimed an NFT from the drop. And now we see that final state automatically, since this query here gets sort of revalidated. It reruns and says, okay, a new NFT has been claimed. This check over here for how many NFTs I own reruns after that mint has been completed and says, okay, now do you own any NFTs? It says, oh, it looks like that has been updated. The owned NFTs is no longer of length 0. So we skip this and we reach this final block here where we're ready to play our game. So if we click the play game button here, we'll be taken to the /play page, which doesn't exist yet, which is what we're going to create now. So back in Visual Studio Code now, we'll create a new file within the pages folder called play.tsx, and this is going to be our play page, obviously, and represents where the user will interact with all of the smart contracts that we created. And the play page is broken down into many components, and I'll show you why we're breaking it down into components and what each of those components are. So here, if we have a quick look at our demo, here is our demo page of our final deployment. I'll quickly refresh this. So you can see we have several different components. In the top left here, we have the equipped items components, where it loads the NFT that the user owns. So this is actually just hard-coded to be this character if you own one, since we only have one kind of character in this NFT collection. And then the second item here is the currently equipped pickaxe with a token ID that you have staked onto that smart contract. And this component is going to be called owned gear.tsx. And the other component we have beneath that is called the gameplay animation component. And this doesn't really interact with the blockchain at all. It's just kind of a nice little carousel that the little character we have here is supposed to be mining, but in reality is just punching the gold gems. And that's just a little nice to have thing. So that's going to be in a component called gameplay animation.tsx. And on the right side here, we have the gold gems information for this currently connected wallet. Now here's actually two components. One of those components is nested inside of the other. So the first component we have is this surrounding component, which is just called rewards. So let's go ahead and create that rewards component here. So rewards.tsx. And the balance here is going to be the currently connected wallet's balance of that ERC20 token. And beneath that, we have a read from the smart contract of how many rewards are owed to this currently connected wallet. So we're reading that available rewards function on our smart contract. And it looks like I have a balance of 5,000. I have unclaimed 65 ready to be claimed for my wallet address on the smart contract. And earned within this session is the nested component. Now this isn't interacting with the blockchain either. It just gives us this nice kind of idle game feel where this big number keeps going up and up and up every couple of times per second, or a few times per second. And beneath that, we have the claim button, which is part of the rewards. So you can actually claim and call that claim rewards function on the smart contract. So that is the rewards component. And within that component, we have the approx rewards.tsx component, which is going to be this earned this session. And within that component, we'll start a timer when the user hits the page. And every couple of times every second, we will update that value to be an approximation of how many rewards you've earned since you reached the page. So current gear is the equipped items, and the owned gear is this section here. So this is called owned gear, and this top left one is called current gear. So that's the equipped gear versus the other gear that's available in your wallet. Beneath that, we have the shop section, which is kind of just really showing all of the NFTs available to be claimed or minted from the Pickaxe NFT collection. So we've converted it into a shop here where we have one component called shop. So shop.tsx. And within that shop, we have multiple shop items. So you can see we have an item where you can buy the stone pickaxe, you can buy the stone hammer, the green wand, etc., etc. So we'll have another component called shop item. And the final component that we're missing is the actual loading state. So we have just a simple loading component where it says loading ... inside of a p tag here. So we'll say loading section.tsx. So that's it for our components. Now we'll use all of these components inside the play page. And the role of this page is actually just to connect to the smart contracts and load any of the information that we need, and then pass down or provide the components with that information. So on the play page, we'll connect to all 4 of our smart contracts, we'll load that information, and then we'll just render each of these individual components, and they'll have the available information they need to display that on the UI. All right, so let's code up the play page now. The first thing we're going to do is we're going to import the logic that we're going to use from the React SDK. So again, we have the connect wallet component, the use address component, the use contract, which allows us to connect to our custom mining contract from the thirdweb dashboard. So we'll use the address that we imported from the contract addresses here to connect to that contract, as well as a use edition drop to connect to both our NFT collections for the pickaxes as well as the characters. And then the use token will obviously be connecting to the ERC20 token, the gems contract address. We're importing React. We're importing all of these components that we created inside the components folder. We're again importing all of the contract addresses so that we can use those inside the hooks to connect to our smart contracts. And then finally, we just have some styles. Again, you can copy the styles that I have from the full project in the description. So within our export default function play here, the first thing we do is we connect to the user's wallet. I'll just zoom in here. We connect to the user's wallet with the use address hook here. We connect to all 4 of our smart contracts. So we're saying use contract to connect to the mining address, and we're destructuring contract. The way that use contract works is a little different to the pre-built contracts. You actually have to destructure the contract out of the use contract hook. And then we've seen this before, so we're connecting to our use edition drop for the characters, use edition drop for the pickaxes, use token for the gems address here, the gem token address. And then beneath all of our contracts that we're connecting to here, what we're going to do is, again, if there is no address, then we'll force the user to see the connect wallet button. Once they've connected, this address will then be detected. They'll be able to skip this block here, which is then where we return the main gameplay screen. So we have a return of div with some styles in it. And here we make a check to see if the mining contract has loaded, if the character contract has loaded, if the token contract, if the pickaxe contract have all loaded. So if all of these have successfully connected, then we're ready to pass that information down to the components that we created. So if this is true, if we've loaded all of them, then we can render the current gear component, which, if you remember, is that equipped items component in the top left, where it shows the user's NFT from the character collection, as well as the user's NFT from the pickaxe collection. So we pass down the contract that we've loaded using these hooks. We pass down the whole mining contract, the whole character contract, as well as the pickaxe contract to that component. And then beneath the current gear, we show the rewards. So that, if you recall correctly from our demonstration here, the rewards is this section on the top right here. So we'll show the equipped items. We'll also show the rewards section over here. So those are the information required. And you can see we're passing down the mining contract as well as a token contract this time to that rewards component. So you can see for each component, they depend on information from different smart contracts. To connect to them, we're passing them down to the components as props. And then within the components, we'll just deconstruct those props out of the props. We'll deconstruct the contracts out of the props and start interacting with them directly inside of the components. So beneath this sort of top section here, we're saying before that, we're saying if that information isn't true, we're showing a loading section. So if you recall correctly, then we see this loading flag when the information is loading. So in this state, the loading status of these 4 contracts is false. So we're showing that loading component while we're just connecting to our smart contracts, and then we'll be able to show the information on the components once that's ready. So beneath the top section here, we have a similar pattern where we're saying so this is just a divider, this is a horizontal line, but we say if the pickaxe and the mining contract, then we can show this section. And beneath this, we'll have another loading section when that is false. So if there is a pickaxe contract and a mining contract, we show the your owned pickaxes section, which is this middle section here, which shows the your owned gear component, which we depend on the pickaxe contract and the mining contract to show that information. And we follow a similar pattern here where if we're loading the contract, then we'll show that loading section component. So beneath that, we have another horizontal line here. So this is this line here, and we're going to show the shop beneath that. So we're following that pattern where we say if the pickaxe contract and the token contract have loaded, then we're ready to show the shop component. But if that information is still loading, then we'll show the loading section. So you can see now we have our full page set up where we have all of these components, but none of these components actually do anything just yet. So now we need to write the logic for the components themselves. One thing I'm going to do before jumping into coding up those contracts is I'm going to create a folder called types. And this types folder is going to contain two types, one of which is called contract mapping response, mapping-response.ts, and the other is called edition drop metadata, metadata.ts. And if you're not using TypeScript, you don't need to worry about this, but essentially what we're doing is we're just creating these types for the information that we come back with from the smart contract. So the first type is going to reflect that mapping type or the mapping struct that we created in our smart contract. So the first thing we're going to do is we're going to import the big number type from ethers. Beneath that, we're going to say type contract mapping response is equal to the isData field, which is going to be Boolean. And then if you remember in our smart contract, we had that value field. So the value is going to be a big number. And that represents the uint256 value that we had on our smart contract. And beneath that, we'll export default contract mapping response. So we'll export the default value to be the type that we just created. And the other type that we want is this edition drop metadata. So within this, we're going to do a similar thing. We're going to import JSON from the thirdweb SDK. We're also going to import the big number type from ethers. And then what we'll do here is we will have a type that accepts the metadata as well as the supply. So metadata is going to be a key of string that returns a type of JSON as a value. And then the supply, we have big number. This is just going to be used for the types that we're returning or we're reading from the smart contract so that we can use those in the components themselves. So now we're ready to jump into those components. So now let's build out the current gear component. And the first thing we're going to do again is import all of the functionality that we're going to be using within this component here. So we have the imports from the React SDK, the TypeScript SDK. We have imports from React, and we have those two types that we created, as well as a gameplay animation component and some styles. So we haven't created that gameplay animation component, but we are going to be using it within this current gear component. So after our imports, we define the type of props that we're going to be passing into this component. So if you remember on our index.tsx page here, what we were doing, in the play page, what we're doing in this contract is we're passing in 3 smart contracts as props. So we're loading the smart contracts up here. And once those are loaded, we're rendering this component and passing those contracts down into this component. So what we're going to do is we define this type of props. We're passing in the mining contract, which is going to be a smart contract, passing in the character contract and the pickaxe contract, which are both of type edition drop. So we have these typed props now, and then we can use these inside the functional component. So you can see we're destructuring the props that get passed into this component, typing them as the props that we define here. And you can see in these comments here, it says this component shows the currently equipped miner character as well as the currently equipped character's pickaxe. So if you take a look at our example here, so you can see this is what we're about to render. So we'll load the information from the currently connected wallet, and then we'll display it on the UI. So that's our first thing we need to do, is actually load the currently connected wallet. And we can do that using the use address hook as we have done previously. Beneath that, we'll load the metadata of the token ID 0 for the character NFT in the character NFT collection. So we're saying use NFT, which if you hover over this, it says use this to get an individual NFT token of your NFT contract. So we're loading the metadata of token ID 0 from the character contract that we're passing down as the prop here. So that's going to load the information required for this character here. Then we're saying we have a stateful variable to store the pickaxe that the user currently has staked. So this will either be undefined if they don't have any NFTs staked or they don't have any pickaxes staked onto the contract. Otherwise, it will be the metadata of the NFT that they currently have staked. So what we're going to do now is inside a use effect block, we have this immediately invoked async function, which is just a fancy way of saying, let's run this inside an async block, inside a use effect block. So use effect is a kind of way of loading information when certain variables change. We'll explain that in a little bit. But inside this async function, what we're doing is we're connecting to the mining contract. We're calling the player pickaxe mapping, passing the currently connected wallet address as the key to that mapping. So first of all, we're saying if there's no address, then we can't load information about address that isn't a thing. But if there is an address, then we're ready to load what token ID inside that mapping the currently connected wallet address has. So in essence, all we're doing is just loading the token ID from the player pickaxe mapping here for the currently connected wallet address. And then we're typing that as the type that we just created, which comes back as the isData and the value. So we can read if the NFT is currently staked, as well as the value, the token ID of the NFT that is being staked. And then what we can do if there is a NFT staked with this isData field, we can load the metadata using this get command. So we're saying pickaxe contract.get, which just loads the metadata of a given token ID. So you can see here, get a single NFT metadata, and we're passing in the token ID to that call. So if there is a pickaxe on the NFT staking contract, I guess we could call it, then we're loading the information or the metadata of that token ID from the collection. And then all we're doing here is just setting that value in state. So then we can use the metadata of the pickaxe to show it on the UI. And what I was trying to sort of explain before is this use effect block gets rerun every time one of these three values changes. So if the user's address changes or the mining contract changes or the pickaxe contract changes, then what we're doing is we're rerunning this code. So you can see how that's useful when a user connects their wallet, then we'll get past this point. Or if the mining contract changes, we'll load this information again, or if the pickaxe contract changes, that's kind of less relevant because that's probably not going to happen in our case, but you can see why that would be useful. So all we're doing in this block is we're loading the information and setting it in state. So now we have the currently staked pickaxe NFT and the metadata of that stored here in line 28. All right, so beneath the use effect block, what we're doing is we're rendering the UI. So now we have all of the information that we need to start rendering this on the UI. The first thing we do is we load the equipped items. So we have some text here saying equipped items, and then we have a div that just has some styling. I was too lazy to put this in CSS, so I just put it in here. And then we show, first of all, the thirdweb NFT media, which is a UI component that renders NFT metadata of the player NFT. So if you recall up here on line 27, we loaded the metadata of the player character NFT. So we now have that in a variable called player NFT. So we're saying if player NFT has loaded, then we'll render the metadata of the player NFT. And that just shows the actual metadata of the NFT. So what we're going to have here is a little box with our character inside of it, essentially. And beneath that, if you remember on our UI here, this is the first box, and this second box is the actual pickaxe NFT that is staked. So what we're going to do now is we're going to say if there's a pickaxe, then we'll show another thirdweb NFT media component with the metadata of that pickaxe. So let's pass that in here. We have another div with a gray outline, and we say if there's a pickaxe, then let's render that using the thirdweb NFT media, passing in the metadata of the NFT, and then we're good to go. We now have both of these boxes with the equipped items text above it. Beneath that, we're going to render the gameplay animation component that we're about to create next. So we have another div with some simple styling, and then within that, we have the mine.gif, which if you recall correctly, we have that in the public folder here. So this is just going to render our little punching animation here. Beneath that, we're going to have the gameplay animation component, which we'll create just in a second. And we're passing in the pickaxe contract to that component as well. So our gameplay animation component is actually very simple. We just have 3 imports. One is the styles, one is just React, and then we're importing the type here as well so that we can use that in the component. But all this component does is essentially render many of these gold gems in sort of this slider. And the CSS I got from a tutorial. So if you want to use the same CSS as I did, it comes from this gameplay.module.css. So we take a look at this. You can see we're using keyframes and a slider, as well as some sort of CSS magic to make it slide across the screen with this animation here of scrolling to sort of the left in an infinite manner. And then we get this effect on the UI where it sort of just slides these 10-ish gold gems across the screen. It's kind of hacky the way that we're doing it, as you'll see in a short second here. But all we're doing is we have a const called gold gem. We have this div that stores the image, which I don't think we actually have. We might need to add the goldgem.png. Let's just quickly bring that here. So the goldgem.png is this one here, where we have the gold gem. So let's drag that into the public folder here. So we're loading that into an image, and then beneath the gold gem declaration here, we have a type where we're passing in the actual pickaxe contract, because we're going to say if the sort of currently connected wallet doesn't have a pickaxe staked, the text is just going to say, I need a pickaxe. So it's going to say, I need a pickaxe if you don't have one staked. And then once he does have a pickaxe, he's going to start punching those gems and mining them. So you'll see here in the gameplay animation component, we're again deconstructing the pickaxe contract that we're passing down as props in this gameplay animation component here. So we're getting the pickaxe component itself, pickaxe contract itself, and then we get that inside of the props here. And as you can see, we're saying if there's not a pickaxe contract, if that pickaxe contract hasn't loaded, or if the user doesn't have the pickaxe loaded onto their mining contract, then we say, I need a pickaxe while that information is loading. But if they do have a pickaxe and that pickaxe contract has been loaded, then we'll have another div that uses some CSS magic to sort of show that infinite sort of carousel sliding across the screen. Within that, all we're going to do is we're just going to render a bunch of gold gems sliding across the screen. So you could probably do this a lot cleaner if you just put it in an array and had some mapping logic here. But this is just the hacky way that I've done it, where I've just pasted, 10, 15 of these gold gem components that we have up here. And that gives us this nice effect where we have these gold gems sliding across the screen in this infinite carousel here. So on the rewards component, we're following a very similar pattern where we're just importing everything that we need to use from the thirdweb React and TypeScript SDKs. So we have React, we have from our React SDK, we have the thirdweb NFT media component again to render the metadata of the NFTs. We have the use addressed hook to get the currently connected wallet address. And we're using use contract call and use contract data, which is the write and read hooks to read from our mining contract. So with the custom contract that we deployed, we're using use contract call to run the transactions or those write operations onto the contract. And we're using use contract data to read information from that contract. So this is kind of a write hook and this is a read hook just for the custom contract. So the use metadata hook is to load metadata about our ERC20 token. So we'll get the metadata of the actual gold gems. So we'll be able to see the image, the name, and all of the metadata that we uploaded to the thirdweb dashboard. The use token balance hook is going to it's going to show the balance of the token. So it's pretty self-explanatory. It's just going to load how many gold gems we have from the actual token contract. Web3 button we're already familiar with, and we're just importing some types that we're going to be using for TypeScript here, as well as the approx rewards component that we're going to create next. So beneath our imports, we're again following this similar pattern where we have types of props that we're going to be passing in to this component where we have those two contracts that we're passing in that we depend on for the data that we're going to load and utilize in this component. So we have type props, we're passing in the mining contract as well as a token contract, and this is a new type that we imported from the thirdweb dev/SDK library here where we're just typing the prop here as a token. So once we've got all of that set up, we again follow the same pattern where we're importing the contract, we're getting those with the types from the props type here. And as you can see in this comment, we have this component shows the metadata of the token itself. So we're going to show the gold gem on the UI here. So we're going to show the metadata. This is loaded dynamically from the contract. We're going to show the amount this wallet holds of this token, which is going to be this balance line here. And then we're going to show the unclaimed rewards from the mining contract. Within within this component, we'll also show this approx rewards, which doesn't depend on any blockchain logic. It's just a purely client-side calculation. And finally, we'll have this claim button here. So that's where the use contract call is going to be utilized. We're going to call the claim function on our smart contract to actually claim the rewards or the gems that we are owed. All right, so let's get into it. We have the use address hook, first of all. We again use the use metadata hook, and we're following this pattern where we deconstruct the data out of the object that gets returned from use metadata. We're renaming that data field to be called token metadata, and we follow the same pattern for use token balance. So we're deconstructing the data, renaming that to current balance. You can see how useful these hooks are because they follow all the same pattern. You're literally just doing the same thing, getting different information from the smart contracts, and you can add awesome stuff like the is loading here. So you can say is loading or is error with all of these hooks, which is a great feature. So beneath those two, we have use contract data, which is another read function where we're deconstructing the data and renaming it to unclaimed amount. And we're calling the unclaimed amount function on our smart contract, which I don't actually think is correct. We'll go ahead and fix that in a little bit. But I think the function that we want to read is actually called, if we open this up, I think the function that we want to read is called, sorry, we'll bring this up here. Open up the terminal. We'll go back to our contract, code this. And I think the function we're actually interested in is unclaimed amount. I think it's actually called calculate rewards. So we're going to be reading calculate rewards here, not unclaimed amount. So we'll rename that in a short second. But as we progress through this, we're also using the use contract call to call the claim function here. So this is just calling the claim function on our smart contract, and we'll use that with the mutate. So when you're writing, you don't deconstruct the data, you deconstruct the mutate out of the object that gets returned from this hook. So now we've got all of the information that we need to render the information on the UI. So within the return block here, what we're doing is we have a div with some simple styling. We have a text that says your gold gems. You can see where this is going as we already have a preview here. So we're going to load the metadata. We're going to load all of this information and display that. So the first thing is if the token metadata has loaded, then we'll render that metadata using, again, the thirdweb NFT media component, passing in the actual token metadata into that component, and that renders the image for us here. So then beneath that, we're going to use the balance that we loaded from this use token balance, and we're formatting that to the display value. So we have the balance here. So we say balance is equal to that, and that's what this block is here. Beneath that, we have the unclaimed amount, and this is where the unclaimed function comes in here, where we're loading the owed rewards from the smart contract. And this is wrong. We're just going to go ahead and fix that in a short second, but this is formatting the unclaimed amount into the readable human format. So ethers.utils.format units converts it to a big number to something that humans can read on the UI here. And beneath that, we have the approx rewards component passing in the mining contract, which we're going to create after this component. Beneath that, we have the Web3 button of claim. And this calls that claim hook that we deconstructed out of the use contract call. And this just takes in 0 parameters since the message.sender is actually the person that we're claiming to. So we have a Web3 button, pass the address of the mining contract as the first parameter of contract address here. The second parameter is that action where we just call the claim hook here, and that is it for this component. So let's quickly go back and fix this string here. This shouldn't be unclaimed amount. This should be calculate rewards. Calculate rewards. And what we're doing here is we have the mining contract, we have the calculate rewards. I'm just looking at the documentation here. I think this might actually be not required in here. I think we can put this in the, no, that's good. That's good there, since this is the read operation. So the 3 parameters that we have are the contract, first of all. The second one is the actual name of the function you want to call on that contract. The third one is an array of arguments that you're passing into that contract function. So if you see in our actual smart contract here, what we have in the calculate rewards function is the address of the player that you want to calculate to. So that's the parameter that we're passing in this array here. All right, so that's it for the rewards component. Now we just need to create this approximate rewards component here. So within the props rewards component, we're following a very similar pattern where we import all of the stuff that we're going to be using. So we have the type, we have some imports from React, Ethers, and the thirdweb, React, and TypeScript SDK. So we're using the use address hook, the smart contract type, and we'll use Ethers to format some of the results that we get back. We'll use use effect and use state to update those values in sort of a repetitive cycle in a set interval function within a use effect. And then we have the contract mapping response, which is just the type that we created. And we're following a very similar pattern here again, where we have the type, we accept that mining contract as a prop into this component. And then within our component here, what we're doing is we're grabbing that mining contract and then we'll be able to utilize it. So this component is a little hacky. We have this variable called every millisecond amount, which kind of hacks this way of grabbing the amount that a user might earn per second. So I've made a rough assumption here that every block will take around 2.1 seconds to be mined. And then we're making some calculation here where we have that value set to 10 trillion down here. And if you remember, that is in that 18 decimal format. So they're earning that value every millisecond. And then what we do is we store these values in a stateful variable. So we have a stateful variable called amount and multiplier. So the multiplier, if you remember in our smart contract, we had a multiplier for the calculation of the rewards here, where the token ID is being used to multiply the rewards that the player earns. So we're going to load that information as well as the rewards that they're earning every second. So let's go ahead and write that in this use effect block here. So if there's no address, we can't load this information because we don't know the address we're checking to load the rewards for. But if there is an address, then what we can do is we'll call the player pickaxe with the address being passed in as the main argument here. And we're returning that type as a contract mapping response. And what we'll do is we'll say if they do have a pickaxe staked, then we can read the token ID, set the multiplier to be equal to the token ID plus 1. Otherwise, if they don't have a token, then they're not earning any rewards since they don't have a token staked, so they won't earn any of the gems. So the multiplier will be 0 if that token is unstaked. All right, so then beneath we have a kind of hacky use effect set interval where we set the amount every 100 milliseconds to be amount plus every millisecond amount. So we're updating this value called amount in state to be the value that we calculated based on this sort of hacky calculation here. And beneath that, we return this on the UI. So we have earned this session with a space here, and then we actually calculate the amount times the multiplier to a fixed value with the sort of fallback here value being error if something went wrong calculating this value. So you can kind of see how this is sort of a hacked together solution where all of these calculations are being approximated on the client side, and feel free to make improvements to this. It's just kind of a fun little aspect of the game where you have this constantly refreshing value, and that gets multiplied by the token ID multiplier that is on the smart contract. So now we're going to move on from this top section here. So we've written the equipped items, we've written the gameplay animation, we have the reward section here, and we also have the earn this session section. Now we have 3 components to go. We have the owned pickaxes, and we have the shop and the shop item, and I believe we need the loading section as well. So we've got 4 components to go. Let's go ahead and build out the your owned pickaxes component now. All right, so for the owned gear component, what we want to do is load the pickaxe NFTs that the user has within a wallet that they haven't staked onto the smart contract. So for this, we're going to follow the exact same pattern. We'll import all of the required logic. So we have the thirdweb NFT media, use address, use owned NFTs, and the Web3 button, which is all stuff that we've seen before. We have the types that we're going to type the props as in this next line here. So we have pickaxe contract is of type edition drop, mining contract is of type smart contract. And this is the exact same pattern that we've seen in all of the previous components. We're just going to speed through the imports here and go to the actual functional component. So you can see within the comments here, we have this component shows the pickaxes that the wallet currently has that aren't staked into the staking contract, and a button as well underneath the image that we're going to show using this thirdweb NFT media that allows them to stake the pickaxe NFT onto the mining smart contract. So again, we're following the exact same pattern here where we deconstruct the pickaxe contract as well as a mining contract out of the props that get passed down to this component from this play field, the play page rather here. So we're passing down the pickaxe contract as well as the mining contract. We're getting those available inside of this component here. So we're once again using the use address hook to grab the currently connected wallet address. Then we're using the use owned NFTs as we did in the index.tsx page. But this time we're using it to load the owned pickaxe contracts, sorry, the pickaxe NFTs rather than the character NFTs. So we're loading all of the pickaxes within this wallet, passing in that address from the use address as the second parameter here. We're renaming the data to be owned pickaxes, and we're also grabbing that is loading Boolean flag so that we can show this loading state here, where we say if it is loading, then return the loading section. But if it is not loading, then we can continue with the rest of this component. And beneath this, we're going to write the function that actually equips or stakes the token, the pickaxe NFT onto the mining contract. So we have an async function called equip, and this accepts an ID of type big number. And what we're first doing is if there's not a currently connected wallet address, which should never really be the case since we're using the Web3 button, we'll return immediately out of this function because you can't equip if you don't have a currently connected wallet address. We don't know who the NFT is coming from. So that's just kind of a safety check. But beneath that, we can go on with the rest of the function. So the first thing we do is we check if the mining contract has approval of the currently connected wallet addresses pickaxe NFTs. And approval refers to the ability of the mining contract to transfer the NFTs from the address. So what we're saying here is has approval is equal to the fact that the pickaxe either does or doesn't have the permission to transfer the NFTs, because if you remember, inside of our stake function here, we're transferring from the message.sender to this contract. So the contract is actually responsible for transferring from the sender to this contract. That's why we need to make this check here. And if approval is false, so meaning the mining contract doesn't have permission to do that yet, then we need to set that permission to be true, which is what we're doing here. So we're saying if they don't have approval, if our mining address doesn't have approval, then we need to ask the user, hey, can the mining contract address have permission to transfer your pickaxes? And then the user will approve it. Then we can continue on. The function will then be callable, where we can say, we can now call that stake function to allow the user to transfer or equip that item inside of our game. And to close out the equip function here, all we're going to do is quickly refresh the page so all of that information is reflected on the UI and the user feels that kind of, okay, my transaction went through. Now the information is kind of reloading again. So let's close off the equip function here and let's continue on with the UI for the owned gear component. What we're going to do is we're going to return a div with some simple styling here, and we're going to iterate over all of the owned pickaxes. So we're looping over all of the owned pickaxes where we can access the current iteration or the current pickaxe that we're looking at in this P variable here. And what we're going to do is we're going to render the metadata of each pickaxe in the owned pickaxes array. So you can see we're transforming each pickaxe into a div, and within that div, we're going to render the metadata of that NFT. So you can see here, we pass in the metadata into this thirdweb NFT metadata component. We have some styling and the height is just going to be set to 64. So that's just some styling. And we get this effect where each of the owned pickaxes will look something similar to this. We don't have any owned pickaxes in this currently connected wallet apparently, but it will look very similar to this component here in the shop where we have the metadata of the image and we have the name. I believe we have the name beneath this. Yep. So we have the name of the pickaxe that the user owns. And then beneath that, we'll have a Web3 button component that allows the user to equip that NFT by calling this equip function here that says, okay, mining contract.call, stake the ID that got passed in. And as you can see, we're passing in the token ID into that equip function for each of these Web3 buttons that we've created. All right. So that's it for our owned gear component. The next one we want to do, I believe, is the shop. So let's move on to creating that shop component now. So the shop is very simple. All we want to do is just load the available NFTs to be claimed from the Pickaxe NFT collection. And then we just want to render those on the UI into a shop item component. So all we're doing is importing all of the logic we need. Again, we have the type props following the exact same pattern that we have been with all of these components, passing in deconstructing the pickaxe contract out of the props of this component. And we have a nice comment here that says all of the pickaxes available will be displayed with their price, as well as a button that allows you to buy it from the shop. All right, so within the shop, we have the use NFTs, which grabs all of the available NFTs inside the pickaxe contract. So we're loading all 5 of the pickaxes with their metadata. And all we do, again, is just loop over each of the available pickaxes NFTs inside that array, convert it into a div here, and this is just returning the shop item component. So we're transforming the array of all NFTs from that pickaxe contract, accessing it within this P variable here, and we'll have 5 of those converted into this shop item component here. So this one's very simple. All we're doing is just looping and converting them into another component. So let's build out that shop item component next. So within the shop item component, you can see what we want to do is we want to render the metadata of the NFT. So we have the image, we have the name, we have the price, and the price actually comes from the claim condition. So that's the one kind of new thing that we're introducing into this component here. So let's go ahead and import all of the functionality. And the new thing that we're using here is this use active claim condition hook. And as the name suggests, this reads the active claim condition of a NFT. So we're using this to read the price is essentially why we're importing this, and we'll pass in the token ID, we'll get back the active claim condition for each of those tokens, and we'll read the price and render that price on the UI. So we gain this kind of shop effect where we can show the metadata of each of the NFTs as well as the price coming from that claim condition. All right, so I'm gonna kind of skim over the rest of these imports as we've kind of already seen all of these before. Beneath that, we followed the same pattern. We're passing in the contract, and this time instead of a contract for the second parameter, we are actually passing in the NFT metadata itself. So we have the contract as well as a metadata that we're looking at so that we can use that to grab the token ID and pass that into the use active claim condition hook. All right, so within the actual function, we have the item and pickaxe contract deconstructed. What we're doing is we have the const address, grab the currently connected wallet address. Beneath that, we're reading the active claim condition of the token ID that we're currently looking at. So the 2 arguments passed in here are the pickaxe contract as the actual NFT contract itself, as well as the token ID of the token that we want to see the claim condition for. And we're destructuring the data field out of that, renaming it to claim condition, and that's kind of the same pattern that we followed for all of these use X, use Y hooks. All right, so beneath that, we're using a write hook here. So we're deconstructing mutate instead of data out of this hook. We're renaming that to a function called claim NFT. And as the name suggests, we're claiming an NFT from this pickaxe contract from this function here. So what we're going to do beneath that is we'll write a buy function that, as you can imagine, is allowing the user to mint or claim an NFT from the shop. We exit out of this function if there is no address somehow. We can't claim to a wallet that we don't know what it is. Within this function, we're going to use that hook, that function that we got from the hook that we just deconstructed here, to pass in the to address is the currently connected wallet address. The token ID is the ID that the user is trying to buy, and the quantity is just going to be hard-coded to 1. So this allows the user to pick an NFT that they want to buy from the shop. We'll mint that NFT to them, and if that fails, we'll just show them an alert that says something went wrong. Are you sure you can afford it? Like, do you have enough gems that you can actually buy this NFT? So that's it for the buy function. We'll move on to the UI here. We're again rendering a div with some styles. And all we're doing here is rendering the thirdweb NFT media to show the metadata of that NFT that we're loading. And this one is being passed in by the item prop here. So we're rendering the actual metadata of the pickaxe NFT itself. So we'll load the metadata of the image here within this thirdweb NFT media component, passing in the metadata, adding some styles. Beneath that, again, we'll show the name. And here is where we'll use the active claim condition to show the price. So we're saying the price is equal to if the claim condition has loaded and the price. So we're formatting it using ethers.utils.formatUnits, passing in the price that comes from that claim condition we got from the use active claim condition here. And beneath that, we have another Web3 button that allows the user to buy or claim / mint the NFT from the actual drop. So that's it for this component. We've kind of gone through everything. Here we have the metadata, we have the name, we have the price, and we have the buy button using this Web3 button here to make sure they have a connected wallet and make sure they are on the correct network as well. The final component we need is this loading section here. And as you can imagine, it's very simple. We're just returning a div that has the loading text within it. All right, so if we save this and let's open up the terminal, we'll run the yarn dev command here. We'll visit localhost 3000, open that up. And as you can see, the connect wallet button kind of flashed there, but I have already connected my wallet to localhost 3000. We have already claimed one of these NFTs from that character collection, so we don't see that edition drop. We're ready to play the game. Let's click this. It takes us to the play page. We can see all of these loading states. All of the information loads in. So we don't have any owned pickaxes. We don't have an item equipped. So our little guy says, I need a pickaxe. And then our unclaimed is currently 0. And this session is 0 since we don't have a pickaxe equipped. Let's go ahead and buy the stone pickaxe here. This is a price of 0 gems apparently. And let's hopefully see this pop up in MetaMask here. Here we go. We'll claim this from the drop. And once this is done, we should see the transaction go through here onto the test network. And if we take a look at our component here in the shop item, what we said was try to claim this. And then once that is done, once that is done, what we should see is, if we quickly refresh this page here, what we should see is we now have an owned pickaxe here since that NFT has been minted into this wallet. So as you can see, we now own this stone pickaxe and we have this equip button, which will stake it. But first it will ask us if we want to grant this mining contract permission to transfer our NFTs from this NFT collection. So let's go ahead and click the equip button now. And as you can see, it's going to ask us, first of all, do you want it to give access to all of your NFT? And that looks really sus, but all it's asking is if you want to give access to this collection. And I've called my collection NFT. It's not asking to access all of the NFTs, so that's poor naming on my behalf, but it's asking to have access to all of the NFTs from this specific collection. And you can see this is a set approval for all transaction, which just means approved all of your NFT. If I actually click into this, you can see this is specific to the pickaxes here. It's not all of the NFTs in my wallet. I know that looks pretty bad, but that's what it's asking. So that is this line here where we said in the owned gear, we call the equip function. And if you remember, the mining contract needs permission to transfer NFTs from your wallet to its address. So what it's doing is, okay, this mining contract doesn't have permission to transfer. So it's going to ask for this set approval for all over the pickaxe contracts specifically to this mining address. So here's where we are in code. So we don't have approval yet. We're going to ask for approval. And if we await that, we'll go ahead and confirm that. So we're granting the mining contract the approval to transfer our pickaxe NFTs. Once that goes through, we'll hit this call here, where we have a second call asking us to actually stake that NFT. So now the mining contract has that permission to transfer the NFTs. We can call the stake function here. So let's go ahead and stake our NFT. And what we should see is in this equip call, once that goes through, we'll refresh the page. And as you can see, it's refreshed in the background. And the equipped items now is our pickaxe. And we've started to earn these rewards. So it looks like one thing is not going well for us is this unclaimed section here. So I think we might need to go back and fix that up. The unclaimed comes from the rewards here. So as you can see, this should be coming from this use contract data here. And if we take a look at the calculate rewards function, that accepts the player address. So I'm not sure why this is not happy with us. Let's take a look. I think it's because it's in an array, and that looks it. So it's sort of, the difference was that I just deleted the array from the parameters that we're passing into this hook. So instead of passing the arguments into the use contract data, that's just a mistake on my behalf. It doesn't need to be an array. You can just pass them in one by one like I am here. So we're passing in the one and only parameter that we need for that contract call, which is the currently connected wallet address. So now we can see up here, we have the unclaimed rewards. We also have the balance, and we have this kind of hacky refresh every couple of milliseconds to show how many they have earned in this session. And if the final thing we want to do is actually claim the tokens out of this mining contract, and I'm kind of expecting this to fail, as you can see here, because the execution reverted, the ERC20 transfer amount exceeds balance. And in English, that means the mining contract doesn't have the required tokens to actually transfer you or pay you the rewards, because we need to actually transfer our mining address, the tokens, so that it can pay out other wallets. So if we go to our contract addresses here, copy and paste this, and we'll open this up inside the thirdweb dashboard here. And what we're going to do is we're going to transfer it some of our gold gems. So if we open up the gems address here, open that up as well. Let's copy the address of our mining contract, and let's go to the tokens tab of our gold gems. Let's click on the transfer button. We'll paste in the address of the mining contract itself. Let's give our mining contract 1,000 gold gems, and then click the transfer button here. We'll go ahead and approve the transfer transaction. So let's transfer our smart contract 1,000 gems. And once that goes through, the actual mining contract will have the balance of the gold gem tokens so that it can actually pay those out. Because right now, if you think about it, all the contract is doing is really just transferring the tokens to the person trying to claim them. And since it doesn't have any of those tokens, it's failing because it's trying to send more than it actually has, or more balance than it owns. So that transfer has gone through. Let's go back to our page here. Let's go ahead and click the claim button. And this time that transaction should go through. As you can see, we're running this claim function now. And we should see, probably be pretty hard to tell our balance going up here, but once that transaction does go through, we should see that balance number go up. And I don't know if it did, but let's give it a refresh. 08562. And we are now at 08757. So that has gone through. And that is pretty much it for our game. So if you have any questions about this build, you can dive right into our Discord server, where you'll find all of the members of thirdweb to help you out building in your Web3 projects, among many, many other awesome Web3 developers inside of that community. The link will be in the description. But if you enjoyed today's build and you want to see more free, awesome Web3 content like this one, remember to like the video and subscribe to the thirdweb channel. But with that said, we'll see you in the next one.